Today's problem was submitted by a viewer, and it says, for which value of k is root 2016 plus root 56 equal to 14 to the k? Okay. So my instinct here is to square things, try and get rid of these square roots. So 56 is not a perfect square. 2016 is, I'm not sure if it's a perfect square. Probably not. But I wonder if the product of 2016 and 56 is a perfect square. In which case squaring this would work. So let's write out the prime factorizations of these numbers. 56 is equal to 7 times 8, which is 7 times 2 cubed. 2016 is 2 times 1008, which is equal to 2 squared times 504, which is equal to 2 cubed times 257. 257. I wonder if that's divisible by 7. No. So this thing is not going to be equal to, 2016 plus 56, if I square it, I'm not going to get an integer. When I look at the answers, it's a multiple choice question, and the answers are all fractions, but some have a denominator of 4. So maybe I have to raise it to a power of 4 to get an integer. Mm. 257. Is that a prime? What happens if I just raise this to the power 4? So I have x plus y to the power 4 is equal to x to the 4 plus 4 x cubed y plus man, is it 10? Oh, 6. Okay. So x is 2016 to the power of a half, and y is 56 to the power of a half. So this gives us 2016 squared plus 4 2016 to the 3 over 2 times 56 to the 1 over 2 plus 6 times 2016 times 56 plus 4 times 2016 to the half times 56 to the 3 over 2 plus 56 squared. I still think we need to write out factorizations of 2016 and so I think 257 is a prime. um, oh, on the right hand side is 14. 2 times 7 to the k. I also did the math wrong here. Okay, start again. 56 is 8 times 7, which is 2 to the 3 times 7. 2016 is, how did I get this wrong? 2 times 1008, which is equal to 2 squared times 504, which is 2 cubed times 252. And I bet you 252 is divisible by 7. Yep, 36. So this is 2 cubed times 7 times 36. Which is 2 cubed times 7 times 2 squared times 3 squared. So 2 to the 5 times 3 squared times 7. Okay, so when I square this thing, I should get an integer. So if I square this, that's equal to 14 to the 2k. This is 2016 plus 56 plus 2 times the square root of 2016 times 56. (2016 plus 56 is 2072 plus 2 times, okay, 2016, 2 to the 5 times 3 squared times 7, and 56 is 2 to the 3 times 7. So we've got 2 to the 8 times 3 squared times 7 squared raised to the power of a half. So now 2 to the 4 times 3 times 7 equals 14 to 2k. Okay. 2072 plus 32 times 21 is equal to 14 to the 2k. Let's do 32 times 21. $672 Um, (14 squared). What is that? (196). 2744 is equal to 196 to the power of k. Should I work out more prime factorizations here? Well, the right-hand side we know is 2 squared times 7 squared to the k. How about 2744? That's divisible by 4. Let's divide it by 2 first. (744 over 2). See, 350 plus 22, 350, 372. And divide this by 2. We get 600 370. This is the same as 1400 minus 28. So 700 minus 14, 686. Two cubed times 343. This must be divisible by 7. (34 minus 28). 63, 7, 9. Okay. So k has to be 3 over 2, which is option D. Oh, silly mistakes, as usual. Arithmetic mistakes in this case. Yeah, I mean, I was very surprised that I was not able to write. I was very surprised when I tried to write the prime factorization of this, and I ended up with something not divisible by 7, given the nature of the question. I was just pretty sure that squaring this would have to give us an integer. So this is completely unnecessary, raising to the 4th power. But I just checked very quickly myself. I divided 2016 by 8 and found where my mistake was. Anyway, if I hadn't made that mistake, this would have been a lot more straightforward. Nice little problem. It's always a little bit surprising to see when you add two irrational square roots together that they can be a nice power of an integer. But yeah, so it goes. So there's your answer. k is equal to 3 over 2. Thanks for watching.